All right, so now we're going to take a function, use a table to just find some values, some points to plot, and then also what we just talked about with the rising and falling, and um, using the leading coefficient and the degree to help shape an idea of what the graph would look like. So the first thing is just make a table of numbers. So we're going to have an x values, some positive, some negative. Find the y values there. You can see that there's turning points in functions when at a certain point they're increasing and then they start to decrease. So the graph flips, and that happens a couple times. Um, in this case, we have a fourth degree polynomial. What you'll find is that you're going to have the amount of turning points one less than whatever the degree is. So you will find that there's 3 turning points in a fourth degree polynomial. A fifth degree will have 4 turning points, and so on. Given last example, we can look at the original function here. Negative coefficient, even degree. So that means they're both going to go down. Left side and right side will be ending going down. All right. So you plot your points. You know that both sides are going down. You can get a general idea of what this function will look like. And again, you got the 3 turning points based on this being a fourth degree. A couple other vocab to talk about. A relative minimum is in a region of the graph the lowest point. So this is not the lowest point of the entire graph because it goes down forever, left and right. But in that middle section, the relative minimum is near 0 to, right? We're not being exact here, so that's why we're saying it's near. It also has 2 relative maximums near those ordered pairs, -2, 6, and 2, 6. Relative maximum, the same idea, right? In that region, it's the highest point. You can also find an average rate of change for a function over a certain interval. So this is an interval, these are both x coordinates. So between an x value of -2 and an x value of 0, what's the average rate of change that occurred in this function? We're going to use the average rate of change formula, which is essentially the slope formula, right? It's y minus y over x minus x. So you have 2 x values that you're given. What you need to do is find the y values that correspond. So when you substitute -2 into the function, you get 6 for y. When you substitute 0 into the function, you get 2 for y. Now you've got 2 ordered pairs. Again, essentially just using slope formula here, and you get that the average rate of change is -2. All right, now there's 2 try it questions. We'll do each separate, right? So pause it now, we'll go over number 3, and then we'll pause again and go over the number 4. Right, so in this case, in this example, you're first going to figure out what's the end behavior of this function based on leading coefficient and degree. And then you're going to fill out the chart. And then we're going to plot those points and get a general sense of what this thing will look like. All right, so pause it now and then come back and check. All right, a couple things here. Well, that's first of all what the graph would look like. Only a few of those points were actually able to be plotted on there because several of them were, the y values were too extreme to fit on. So you can see the table of numbers there. Just simply substituting the x value in and getting a y value, then having to do that several times. The end behaviors of the graph, well, it's a odd degree, so that means we know they're opposites. And then since it's positive, that means it falls to the left and rises to the right. So as x approaches to the right, the y is going up. As the x moves to the left, the y goes down. I know we talked about the turning points. There's probably less turning points than you would expect. That just means there's some inflection and turning that's happening in between the values that we're doing here that you're not seeing. But generally speaking, this is what it would look like. So there's probably some other kind of turn happening that, on this rough sketch, you're just not going to catch. All right, let's look at the next example. So here you're going to find the average rate of change over that interval from 0 to 2. So again, those are the x values. You need to find the y values, get two ordered pairs, and then essentially find the slope between those 2 points. And that will be your average rate of change over that interval for this function. So pause it here and then come back and check your answer. There you go. I apologize. I think I was not paused there while I was writing all that out. So apologize if you had to fast forward or just sat through all that. That's cool. But anyway, I guess you can see what I did. Found the two ordered pairs, 0, 1, and 2, 125. And then just use the slope formula, get 124 over 2, which is 62. So there's your answer. 62 is the average rate of change between those two, between those 2 points over that interval. All right, let's look at the next example.